A lot of people working with regression don't take the time to look to make sure the data is normally distributed, which is a very important part, especially if you have heteroscedasticity. Heteroscedasticity is when your variance isn't equal across your spectrum. So here's a scatter plot overlaid with histograms showing the distribution of data, and so this has a linear regression line. And what you can see is there's a huge amount of stuff in here which is not really varying much from the line, but over on the other end, on the larger values, it varies a lot, right? And we can also tell this because the histogram here shows you that in the early part there's a lot of data points in here, and then they get very scarce. Same thing with the revenue. So that was in population, and for revenue, right? That there's a lot of people, a lot of revenue for in small amounts, and then it fades out to those we're getting a lot from. And the scatter plot really kind of makes you visualize this, but it's this distribution that really is the key. Is that what you want is a nice normal distribution across both of these, because then your regression numbers will be valid. What I've done is I've made a little loop here, so I'm going to highlight my data here and launch the loop, and what you're going to see is this is going to be slowly moving the number from the normal data down to it's going to be a power of 0, which is a logarithmic transformation. And you're going to notice these variances are getting bigger and bigger and bigger. Things are going to shift to the right, but what you'll notice is that we'll end up with a nice distribution around the regression line. So here it goes. And as you can see here, so as I mentioned at the bottom, you start seeing more and more data points starting to be distributed around the regression line. And at the far end, the data is really, it's getting a little closer, but for the most part it doesn't change too much. But now we have a nice distribution. You can see both of these are normally distributed, and the line now, the distances around it from here to here are pretty close to the same as on the other end, and so my regression statistics will be valid.